video on simplifying radical expressions. What we're going to see here is how to take a radical expression like the square root of 48 or the square root of 338 or the square root of 15 times the square root of 180. We're going to see how to simplify that. Okay, we want it to be in lowest terms. Kind of like how you used to have like maybe 5 over 10 and your teacher would tell you, well, we don't want to leave it as 5 over 10, we'd rather see that as 1/2. Kind of the same idea. Okay, this isn't the simplest form, so we want to take it down. Take it down to the absolute simplest possible form. Let's see how we can do that. What we'll do first is you want to factor. You want to get the prime factorization for one of these numbers. So you're going to have a factor tree. So for square root of 48, we're going to have to factor 48. Let's see. 48. We need numbers that multiply together to give me 48. Well, it's even, so I can divide by 2, and I get 24. Well, 2 is prime, but 24 is not. I can divide 24 by 2, and I get 12. And then 12 isn't prime, so I can divide that by 2, because it's even again. I divide that by 2, I get 6. And 6 I can take down to 2 and 3. And now I've got the prime factorization. 48 is 2 times 2 times 2 times 2 times 3. So I'm going to write the square root of 48 as really the square root of 2 times 2 times 2 times 2 times 3. It's the same thing. Alright, now how this works, for every pair of 2's, or for every pair of numbers on the radical, you can take them out. Okay. So I see 2 2's, and I see another 2 2's. That means these 2's are all going to go away. For every pair that you see, one of those numbers appears in front of the radical symbol. Okay? So these 2 2's, they go away, but now they go in front of the radical. These 2 2's, they go away, but now they also go in front of the radical. And we multiply them. There's the radical symbol. 2 came in front, 2 came in front. The reason you can do this, by the way, is 2 times 2 is 4, the square root of 4 is 2. 2 times 2 is 4, the square root of 4 is 2. What's left? We didn't take this out, so that's still under there. This is technically right, but you want to clean it up. You want to make it better. 2 times 2 is 4. So the answer is 4 square root of 3. That's done. Alright? Let's try the square root of 338. It's the same idea. It's going to have more factors because it's a bigger number there. Okay, I'm going to need my calculator for this one. Got 338. We have to factor that. Well, it's even, so I can divide it by 2. 338 divided by 2 should give me, what, 169. Okay. 169. Well, it's not divisible by 2 because it doesn't end in an even number. It's divisible by 3. Let's see. 1 plus 6 is 7. 7 plus 9 is 16. 16 is not divisible by 3. It's not divisible by 4. It's not divisible by 5, 6, maybe 7. Divisible by 7. No, it's not divisible by 7. I try 8, doesn't work. 9 doesn't work. 10 doesn't work. 11 doesn't work. 12 doesn't work. But finally I get to 13, and it does work. And when I divide it by 13, I get 13. Okay, sometimes you have to try a lot of numbers. What would have been helpful to know is that 169 is a perfect square. The square root of 169 is 13, because 13 times 13 gives me 169. That would help a lot. So knowing your perfect squares for 25 is very useful. So I can rewrite this as square root of 2 times 13 times 13. Well, again, for every pair you see under the radical, get rid of them and put one half of the pair, one of those numbers out in front. So I see 2 13's, get rid of both of them, put one out front. 13 goes in front, and these are gone. The 2 is still under the radical. The answer is 13 square root of 2. You can actually check this. If you do 13 square root of 2 on the calculator, you'll get 18.38. And if you do square root of 338, you get the exact same decimal answer. It's exactly the same. You should see it there. That's how you can check to see if you're right. This is as reduced as it gets. Let's keep going. 15 square root of 180. Same idea. We have to factor the 180. Just make sure I'm still in the shop. I am. Square root of 180. Let's factor this. Well, 180 factors into 2 and 90. 90 is even. I can factor that into 2 and 45. And the 45 I can factor into 5 and 9. The 9 I can factor into 3 times 3. Just finding out numbers that multiply together to give me the number above it. These are all my primes. 2 times 2 times 5 times 3 times 3 gives me 180. let's write this as 15 square root of 2 times 2 times 5 times 3 times 3. So it's 15 square root of 2 times 2 times 5 times 3 times 3. For every pair you see, you have to pull it out, pull one of them out to the front. So let's see, there's a pair of 2's and a pair of 3's. So the 15's out in front. This pair of 2's goes away, a 2 goes out front. So 15 times 2. This pair of 3's goes away, and I put a 3 out front. And then the 5's lonely. He doesn't have a partner. Sad for the 5. He stays in there just by himself. And I'm not going to leave this as 15 times 2 times 3. Instead, I'm going to multiply this out. We'll see. 15 times 2 is 30. 30 times 3 is 90. So this says 90 square root of 5. And again, 90 square root of 5 should be the exact same thing as 15 square root of 180. If you do it, you get the same answer both times. Okay, we're going to try 2 more problems. I just have to move the laptop over a little bit. Okay. That should be fine. Right there. Alright. Let me angle this down. Alright. We're actually just going to jump to this one. 9 square root of 18. Okay, 9 square root of 18, this one will be pretty easy, pretty fast. So 18 is easy to factor. 18 factors into 2 and 9. 2 is prime, but 9 can be factored into 3 times 3. Okay, so this really says 9 square root of not 18, but 2 times 3 times 3, which is 18. And just like all the other problems, if you have a pair underneath, which I do, eliminate the pair and put one of those numbers that were in the pair up front. So instead of saying 9 times square root of 2 times 3 times 3, we're going to say 9 times 3. I pulled one 3 out. These are now gone. The 2's left. I don't like to see 9 times 3 because you never have a cashier tell you that your change is 9 times $3. Instead, it's 9 times 3 is 27. So it's 27 square root of 2, and that's done. 27 square root of 2 is the simpler version of 9 square root of 18, simplified. The last problem we're going to do, 2 square root of 242. 242 is another larger number. We're going to have to simplify it. So let's break it down into its prime factors. It's even, so I'm going to divide by 2. When I divide it by 2, I'm going to get 121. That's prime. 121. It's not divisible by 2, it's not divisible by 3, it's not divisible by 4. I mean, you can try for a while. Hopefully, if you remember your 12 by 12 times tables, 11 times 11 gives me 121. Okay, 121 is a perfect square of 11. Okay, so here's my factors. These are both prime. There's no factors of 11 other than 1 and 11. Okay, so let's see. When it says 2 square root of 242, it really says, oops, it really says 2 times the square root of 2 times 11 times 11. Just like all the other problems, anytime you see a pair underneath a radical, pull it out. The 11's go away, 111 out front. So 2 square root of 2 times 11 times 11 really says 2 times, there's the pair, 111 goes outside, and now the pair is gone. The only thing left under here is a 2. So 2 times 11 is 22, square root of 2. That's really all there is to this. Okay, that's how you can simplify radicals for the most part. This is going to be another video on multiplying and dividing radicals as well. It's going to assume that you know what you saw in this video. If you have any questions, feel free to leave a comment in the box. I'll get back to you as soon as I can. And I hope this video was informative, and have a great day. Bye-bye.